Hi everyone, I'm Raluca. I'm from the Game AI group here at Queen Mary, University of London. And I'm going to start very dramatically. Once upon a time, way before ours, there were stories of gods working among humans. One of them was Thyia, the goddess of childbirth and daughter of Hera. Not many stories were actually written about her, and there are very few depictions of her in mythology that I could track down. But she did inspire this work because she helped to create life, and she will now create artificial life, giving the name of the project. And as Thyia was daughter of Hera, Thyia will build upon my Rolling Horizon evolutionary algorithm research and many other interesting pieces of work to develop an AI game-playing entity which runs continuously, learns from the games it plays, and interacts with humans in hopefully meaningful ways. So the usual steps of running an AI algorithm are writing or obtaining the algorithm in some form, setting up a problem domain, pressing run. Then the run ends after some time with some results, maybe some statistics that we extract from that, and the instance of AI no longer exists. And we can then rerun maybe if we want new results. We can rerun the new instance of that AI and get something new out of it. But we could do several tricks, like saving the random seed of the algorithm to run the exact same instance again. But this is just a copy. All the knowledge, experience, and time put into previous experiments would be hard to reuse. But what if AI game players didn't just disappear after we're done with the run? What if there existed artificial game players that continuously played games? They learned from their experiences and kept getting better. What if they interacted with the real world and us through live streaming games, chatting with viewers, accepting suggestions for strategies and games to play, and maybe even forming opinions on popular game titles, or just playing alongside us? In this paper, we introduce the vision behind a new project called Thyia, which focuses around creating a present, continuous, always-on interactive game player. But not everyone would be happy with such a project. For a lot of people, if they were told of such an AI entity, all they'd see is that. And even beyond that, it's worth considering the ethical implications here and the consequences of opening the AI to the outside world communication and what these consequences might be. The AI could be misused depending on the type of messages or the problems people send to it. And if you remember Thyia, Microsoft's Twitter bot, that had to be taken offline after just 16 hours of interacting with the crowd because it became racist. It becomes clear that taking safety precautions and setting some clear boundaries in the use of such a system is important. But what actually is this system that we're proposing? What is it about? We propose a system that draws from many different parts of game-playing research and technologies to create a complex collection of different modules which interact with each other, as well as the real world and us. I'll go through some of these one at a time to discuss some possibilities, difficulties, and some interesting aspects to consider. So let's start from the GameSet module. The first thing I'd like to talk about is the games that the AI would be playing. And I wish I could say it's going to start off playing some epic StarCraft. That's a very dramatic video, but no. It will start from simpler games, but a lot of them. I've been working so far in my PhD with a framework called the General Video Game AI Competition, which contains currently over 160 games, both single and multiplayer. All of them are open source, so it's fairly easy to extract any sort of input you might need for your agent, including game audio, which you might know about if you were at my talk on Wednesday morning about playing video games from sounds. The wide variety of games currently available means that a lot of these are not actually solvable with general methods. We've seen yesterday, actually on Wednesday, that's bad in my notes, that the random agent won the GVGI learning competition. So none of the learning methods actually managed to do any better than random on the problems proposed. So many unsolved games, there's a wide variety of scoring systems and conditions, there's partial observability, single and multiplayer games, and that all sounds like a very good environment in which to set Togelius for a first time. However, the AI system would have to be able to play any game, or problem given, as long as that conformed to some form of API that we set up. Next up, let's talk about what's actually playing the game. And in this context, the game player is going to be a planning or search method that's using a model of the game to simulate possible future moves. We need something that is able to actually play some of these games. And my core PhD research so far has focused on the rolling horizon evolutionary algorithms, which are evolutionary algorithms that are applied online at every game tick to search for some good action plans. Traditionally, these are formed of atomic actions, so something like what is up on the slide, very simple, move left, right, shoot, and whatnot. But there have been several works out there recently that have started looking into how can we make these plans more meaningful and look at possibly goals that could be achieved by the AI instead of the atomic actions. So instead of saying move left, left, right, up, down, shoot, we could say instead go pick up the key, then go to the door. And that's a lot more meaningful and interesting to look at. With much research behind them and relying on not only planning methods for general video game playing, but also extensive evolutionary algorithms research, there are a lot of variations to this algorithm. So also many parameters that can control the search and various aspects of the algorithm, starting from things like how many action sequences it's evolving at a time, to the very structure of the algorithm. And some of these combinations of parameters have been shown to be very good in many of the GVGI games, and even better than the most popular base of complex AI systems, Monte Carlo research. So these all make Rolling Horizon a great point from which to start building the larger system, although other research methods could be integrated later on into this larger system and potentially switch between with some hyper-heuristic algorithm that's deciding how to make use of the strengths of each of the different methods. Next up, let's talk about some learning. Although planning methods, excuse me, planning methods do great in many GVGI games, and not only, but they don't often make the most out of their experiences in previous games played, and often start planning from scratch when they begin a new game. Therefore, introducing some learning methods into this algorithm is a natural progression. You may have seen on Wednesday as well some work on introducing neural networks into the Rolling Horizon algorithm with great results. So we could learn estimations of state values and use this in the heuristics that inform the planning method of what's good and what's not in the world in non-terminal state. We could learn policies to solve various problems. We can learn how the world works and why it works the way it does. The memory of the agent is included separately in the diagram you saw before, but it's related to what the agent learns while playing games. And an interesting difference to be made here is between remembering experience. So what did I do in a particular situation? What sort of objects am I encountering in the world? As opposed to the knowledge about the environment. Why did I do that in the situation? What could I do for a better or a different outcome? Or how does the world work? And all of this can be either general, so we can look at how an avatar can move in general. If I'm pressing some keys, then that probably means my avatar is going to move around the screen. Or it can be game-specific. How do I jump over gaps in the floor? So overall, humans don't only plan and don't only learn. They make plans and learn from the outcomes. So likely combining the two would lead to a better and hopefully more general system. And next, let's look at some optimization. So we talked before about the many parameters that this algorithm could have. And the current implementation of the running horizon algorithm, for example, has over 30 parameters that control various aspects of the search. And it's a given that some combinations of values for these parameters are better than others. So it's important to get a good set which is actually able to deal with all the problems that we would like it to solve. But this is not left without questions and difficulties. The level of granularity should be considered. Do we want to optimize the parameters to be good on average across a large set of games? Do we want specific parameters for a game or a game type to be good and figure out how to switch between them maybe? Or maybe we want different parameters depending on the state of the game. We've seen yesterday in Chiara's best paper presentation that it depends on the game, even what sort of granularity we'd want in our tuning or randomizing of parameters. And when this is all in place, we also have the problem of integration to consider. If we change parameters, it's virtually changing the way the algorithm behaves in the environment. And this might be confusing to a learning system that was used to receiving input from one algorithm, and we're suddenly changing how this behaves. So this needs to also be robust and be able to deal with changes in the larger system. And one option that we're currently considering for this part is the n-tuple bandit evolutionary algorithm, or NTBA, that I'm sure Simon Lucas would be more than happy to talk to you more about. And finally, I don't think I'll have time to look into analytics, so I'll skip to the interaction of the system with the real world. And this is probably one of the most interesting aspects of the system, is the way us humans would be able to interact with the system so that the AI entity would be part of our world and our culture. And here we consider three different aspects. A first would be a direct interaction. So the system would contain some form of natural language processing integration to be able to communicate with us and understand various aspects. This interaction could vary from asking Thyia to play certain games, or ask for thoughts on the games it plays, or even asking to play something together. Then we can look at analytics and understanding what's going on in the brain of the AI, why is it doing the things it's doing, and have it explain to us the decisions it's making. This would be key to debugging and further developing the system. So logging of various information and analyzing or visualizing it for humans is an interesting aspect. And last but not least, the AI could become part of our culture and our community. Live streaming games on Twitch or YouTube would make it easy for the whole world to interact with it, give suggestions maybe for improving its strategies or changing its behavior in some form of meaningful way. And to conclude, what we propose here is a complex system that pulls from a lot of different parts of research to create an AI game-playing entity. And there are already multiple examples of such continuous and present AI in other domains, like pocket assistants. Most of you have probably interacted at some point with Siri or Alexa, and as they develop and gain new abilities, they become more and more part of our world, as Thyia might one day. And one last notable example to leave you with is my cook's Angelina, the game designer, which combines many of the features discussed in this talk in the domain of computational creativity. To end with a point that my supervisors didn't let me include in the paper, Thyia would basically be Angelina's new best friend, playing the game Angelina creates and offering feedback or discussing the games back for an endless loop of creativity, gameplay, and friendship. And if you haven't seen it yet, I wrote a song about all this, which won second place in the video competition yesterday. So do check it out, and thank you for listening.
How would Thyia decide which games she wanted to play with humans?
That's a very interesting question. It could be the humans deciding what games they want to play with Thyia.
Oh, we have a say.
You do have a say, yes. That's always good. But yeah, that's something interesting to consider. It could use different features of games that it knows how to play and decide, okay, I really want to play this game with someone. Anyone want to play it with me? It could be looking at various players and maybe check their previous requests, for example, and see what type of games they like to play and say, okay, maybe this person would like to play this game with me. That would be interesting. There's a lot of different things to explore in that area.
Cool.
Mike?
I don't know, I can just shout if that's better. That was great. I was sitting here thinking literally the same thing as you were saying. So I was like, that's fantastic. You said that Angelina works in the domain of competition creativity. Do you want Thyia to work in that domain as well? Are you interested in creative ways of playing the games as well? Or is that not something that you consider to be creativity or, I don't know?
I think to start off with, it would mainly be focused on solving different problems. So I have different games and I'm trying to figure out how to win them, and that would be it in the beginning. But I think it's interesting to explore more about how can I creatively play so that humans actually enjoy when we're playing together, or how can I creatively lose games so that people actually get something interesting and exciting out of the whole experience. So maybe that could definitely be a future expansion.
One more question.
Christoph?
Thank you. So very interesting talk, and I was wondering, so the idea of experience shaping the AI, I find particularly interesting, and I was wondering, do you think it's possible if you had if C had a sibling, let's say Hyperion, right? Could you have both of these AI run, and do you think they would kind of develop maybe different preferences or different kind of play styles and become different people? Quotation marks?
Yeah, that would definitely be very interesting. I think as humans, what we experience in the world and the community that we're around, it definitely shapes us in a way. So seeing how that could also be transferred into the AI world and have different entities expand from their different experiences, that would definitely be very, very interesting to explore.
Thanks a lot.
Thank you.
Next talk, Santiago did a paper by Jichen and Santiago Ontañón on experience management in multiplayer games.
Right, thanks, Mark. So I'm going to present a joint paper with my co-author, Jichen from Drexel University, and I want to talk to you about experience management, and in particular, experience management in multiplayer games, which we believe hasn't received enough attention. So what I'm going to basically do today is first introduce a little bit experience management, even if I think most of you guys in this room would actually know what it is. Then talk about some potential applications of applying experience management to multiplayer games. and then list a few open challenges. By no means this is supposed to be an exhaustive list. This is just a few open problems or open challenges that we thought would be interesting, and maybe some of them low-hanging fruits to start pushing in this direction. All right. So what is experience management? So experience management, an experience manager is an AI system that automatically adapts an experience or a game based to try to customize it either for a specific user or basically trying to maximize some author's specified goals. So for example, you can think of difficulty adjustment, or one of the earliest examples of experience managers that they used to call them drama managers back then is Peter Weyrock's Mo system that had an evaluation function that, given a story, could evaluate how good that story was going to be. So there was a search process in the background where, as the player was interacting with the story, it would search over the set of possible plot points that could trigger next, so that this story would maximize this evaluation function that he defined, right? And this evaluation function included things such as the story has to follow an Aristotelian arc, right? Start rising in tension and then at the very end lower. Or he had things like a story should not be switching topics constantly. So if I trigger 4 or 5 plot points in a row, they better be talking about the same topic instead of changing topics back and forth, right? So there was a few factors evaluating the story, so that the experience manager in the background was basically triggering plot points to start to maximize this function. This has been applied to many other things, like, for example, difficulty adjustment, as I was saying, or even to personalize experiences in educational games. And it has even been deployed in some commercial games, right? Like the typical example is already getting old, this example, but left for that too is the example that everyone uses as a deployment of EM, experience management in a game. So how does typically an experience manager look? It looks like something like this. So there is some game, and there's a player that interacts with the game. And often experience management goes hand in hand with player modeling. So there is a player model that models whatever aspect of interest that we want to adapt for. For example, if we have an experience manager that adjusts difficulty automatically, so this player modeling module would try to model the skill level, for example, of the current player, right? So based on the current skill level, this is given to experience manager, and for example, the author wants this game to be at a particular level of difficulty, so the experience manager would adapt the game, adding enemies or removing enemies, for example, basically to adjust the difficulty to the current player, right? So this is experience management. So when we apply this to multiplayer games, this idea, basically the question is how well does this idea transfer to multiplayer games? And what happens is that there's many questions that occur in multiplayer games that do not occur in single-player games. Like, for example, if we have more than one player, and if we have a player model, we're going to have multiple player models. So how do we aggregate these player models so that we can adapt the game? Or if we don't want to aggregate them, if we have multiple player models, how do we adapt the game to suit these potentially competing player models of all the players playing in the game, right? And so some of these problems are hard, but the interesting thing is that we believe there's many potential applications for this in the real world. So let me just list a few applications that multiplayer experience management can have. And one of my favorites, for example, would be multiplayer massive online games. So where we have a game that automatically adapts to millions of players. And the way I imagine this, I don't know how many of these MMOs you play, but in these games, typically there's a lot of quests, and one quest, for example, would be rescuing the king that has been kidnapped or whatever. And if there's 1 million players, every single one of these 1 million players rescues that same king that was kidnapped by the same dragon, right? Which doesn't seem to me like very realistic or like the way it should be, but it is the way these games are. So the way I imagine this is if you have, let's say, a story-driven experience manager that constantly adapts this game, probably this experience manager could generate quests for different players and constantly adapt the game based on what the players do, what groups of players do, what the overall population of players do, so that it maintains a consistent story world and is constantly adapted to what players do, basically. So I think this is a little bit beyond what we can do nowadays, but I think it would be an interesting application. And this is related to this idea of AI as game producer that was introduced by Alex Zook and Mark Riddell a few years ago, where the AI doesn't just adapt or model players, but actually takes part in the design and evolution of a particular game. So this might be a little bit too far to achieve right now, but there's many other applications that are more realistic. Like, for example, if we look at educational games or training applications where we have groups, multiplayer EM could have many applications. So experience management has been applied to many, many educational games. This is not something new. But one thing that we know is that learning science shows that learning groups can be beneficial. For example, imagine that there are situations where you can put together a heterogeneous group, and if you ask the group to achieve a task that only the group itself can achieve, because you need the skills of all the different users in the group, this would foster collaboration in a way that you cannot achieve in a single-player game, right? But if we want to apply experience management to these domains, then we need to have experience managers that can model all the different students or users in the systems and coordinate with all of them so they all stay engaged. And the game is adapted to all of them, right? Another interesting application, which is basically the one that led to us writing this paper, because my co-author Jichen is working in this area, is games for health or extra games. And probably the most popular game of this is Pokemon Go. These are basically games that push players or people to basically do exercise, right? And even if games like Pokemon Go were very, very popular, so there's been studies published showing that it is very, very hard to engage players for a long period of time. Basically, even players of Pokemon Go, which is one of the most successful extra games to date, after about 2 or 3 weeks, basically they stop playing and they don't get motivated anymore to do exercise. So we believe that multiplayer extra games could be a way forward, because we could exploit social interaction as an additional motivation to keep actually doing exercise after this 2 to 3 week period. And of course, experience management could contribute to personalizing these games to individual players and to particular groups to maximize engagement. Sorry. But these are just example applications. There can be many others, and in particularly I like one application that probably someone in this room suggested, one of the reviewers suggested, which is assisted board games, like computer-assisted board games, where the EM could automatically adjust the board game to balance difficulty and things like that, which I think could be pretty cool. All right, so I think that there's many applications. I think I made the point. But there's many open challenges that if we want to deploy these kind of things, we have to address. And again, as I was saying before, this is by no means a comprehensive list. It's just some example challenges that would have to be addressed. The first one I want to talk about is player model aggregation. So as I was saying before, most experience management approaches use player modeling. And by a player model, I mean some abstracted representation of whatever aspect of interest we want to model of the player, be it skill, I don't know, preferences, their goals, or whatever it is. So what happens when we have multiple players? So when we have multiple players, we would go to having something like what I show over there, to something more complicated like this, right? Where we have many players, and we might have player models of individual players, but there might be groups in particular that we want to model. So we might have to create models of the groups themselves. And then the experience manager has to take into account all of these models plus the author goals to actually adapt the game. So it might be more complicated. So in order to actually build this, one of the problems is that we basically lack the understanding of how can we aggregate these player models. One very simple idea would be if, let's say, we have a group of 10 players, we build a player model for each one of the 10, and we just aggregate them, let's say, by doing the averaging of the player models. But what that would give us is the model of the average player in the group, not the model of the group, right? So I would like to make the distinction between the model of the average player versus the model of the group itself, right? Which might be different in many situations. And whereas the first one is easy, the second one might not be as easy to do. And also, how can we dynamically group players into that we might be interested to model as a group? In some games, like for example, role-playing games like World of Warcraft or whatever, players naturally do parties, and it might be easy to group players into these groups that we want to model as a group. But in some other games, this might not be as trivial. And again, if we have multiple models, how do we adapt based on those? So this problem might be hard, but there's work in other areas of research that has been done in similar directions. So I think we can actually draw upon some of those to solve this problem. And in particular, I just want to show an example in the case of preference aggregation, right? Which, imagine, let's say, an experience manager that wants to decide which of the next plot points are going to be presented to the players in a group, and it wants to decide that based on preference. Like, for example, we know that some players prefer fighting, some other players prefer dialogue, etc., right? So we might want to have to model the preferences of the players, and if we have multiple players, we have to do preference aggregation. So this same problem arises in many multi-agent systems, and also in group recommender systems that have exactly the same problem, right? So there's been previous work on this. For example, in the area of group recommender systems, there's some systems like music effects or polylens that already address this. And the way they do it, for example, I picked these two because they use two complementary approaches. So music effects, the way it does is it models the preferences of all the players. It then aggregates these preferences, doing some averaging. And then based on these average preferences, it makes recommendations. Polylens does the opposite. It has all the players, or users in their case. It makes recommendations for all of them, and then it aggregates the recommendations. So the aggregation it happens later. It's basically the same idea, but the aggregation happens at two different points. So I think some of these ideas could actually be used also for games, and the question is how can we adapt some of this for the case of experience management. So player model aggregation is one problem. The second one is how do we do this player modeling aggregation dynamically over time? Because when we have, so in our recommender system, we make recommendations once, and then the users watch a movie, and probably that's it. But in a game, if we use this idea of recommender systems to recommend plot points, this happens iteratively, and new problems might arise. For example, consider the following situation. Imagine we have the same experience manager I was saying before that tries to recommend plot points for the game based on the current players. Imagine that we have a group of players, and all of the players but one like fighting, but one of them likes dialogue. So this idea of aggregation will constantly recommend fighting, and the one player that likes dialogue is going to be constantly underserved, right? So that player might be frustrated and eventually might drop the game. So when we do this idea of player model aggregation, we have to take this into account. And actually, in that music effects system I was showing as an example before, they actually saw that in their experiments, and they showed that minority groups, their dissatisfaction with the recommendations grows over time if they do repeated recommendations. So this actually happens. And there's, luckily again, in their literature of recommender systems, there's some work in this direction. Not a lot, but I found one system that actually addresses this. It's a system called pool casting, and it's a system that recommends radio stations for group exercise or for parties, for example, right? Imagine that you're in a class doing spinning and there's 20 people in the room. You need music to motivate everyone to do exercise. So what pool casting does, it does this same exact preference aggregation as the other systems, but it keeps track of how long have we recommended a song that suited a particular user for all the users. And then those users that have not gotten a song that they enjoyed for a long time, they have a higher weight in the aggregation, so this is dynamic. And eventually, we would make recommendations that suit almost all players. This is interesting, might be a bit too simplistic in the case of games, or especially in educational games, where some player needs might be more important than others, and just counting this amount of time might not be enough. But it's some starting point. And there's other problems, like, as I was saying before, how do we do this dynamic grouping? Like, if we have to group players over time into meaningful groups, how do we find these groups is also important. And I'm going to go a bit faster because I see I'm running out of time. A couple of other challenges I wanted to highlight. The third one is that procedural content generation in the context of experience management for multiplayer games. So PCG is one idea usually also associated with experience management, because PCG can allow experience managers to adapt games based on generating new content, right? This has been explored in many areas like narrative, educational games, and others. And one issue that we need to address, or that we need in procedural content generation systems to integrate with experience managers is controllability. We don't want to just generate content, but it has to be content suited for specific users or for specific tasks. And in the case of experience manager for multi-player games, this is complicated by the fact that we don't have just one player model, but we have many. And then we have to address the same problems as we were saying before. How do we generate content, aggregating models, or maintaining fairness over time, etc. And finally, evaluation. So evaluating systems with groups of users is more complicated than evaluating systems with a single user for many reasons, but just highlighting a couple of them. The first is that since we have, let's say that we do a user study, the usual A/B testing, one group doesn't have experience manager, the other one does. When we do this A/B testing, we want to minimize the number of variables that change in the two conditions. But when we have groups, the groups themselves introduce variability because we don't have just one player, but it's a player with a group of other humans that might affect. So we might actually have to have more users, and it's already hard enough to find 20 or 40 users for a user study, let alone finding 200, right? So probably we need some statistical methods to actually compensate for this. And also we might need to have more complex evaluation methods rather than simple A/B testing, just because multi-player experience managers have more moving parts, and just doing a study with EM or without EM might not give us enough information for what we want to evaluate. And so basically that's everything I wanted to say. I hope that you got that the main point of this talk is that there's many potential high-impact applications of multiplayer experience management, like some of those that I listed before, like educational games, massive multiplayer games, or things like games for extra games. There's several open challenges. This for player model aggregation, dynamic aggregation over time, procedural content generation for multiple players, and evaluation are some example of those. And there's the interesting thing is that there's work in other areas like group recommender systems that we can draw upon to actually address some of these problems. And that's it. Thank you.
Very interesting. You obviously have a lot of knowledge of related work in group recommenders, etc. But I was just thinking that when you play a game, because of the interactivity, you can't just take a bunch of player models because they might actually change based on the group. So I am a different person when I'm playing a game with my family, different when I'm playing, the board game store here at CoG. So I wonder whether there's more.
Right. So I have to admit we had not thought of that, but that's a good point. The way you behave depends on the context, and different groups are different contexts, so probably you will behave differently. So I don't know how could we address that, but probably we need player modeling techniques that can actually account for that, either by constantly adapting your player model as you play to account for your difference in behavior, or some other way. But yeah, I don't think I have many insights into that. But
it's a very interesting topic.
Thanks.
Related to some work that we're doing and sort of trying to build kind of a collaborative narrative-based environment. And in that work, one of the things is not just the content you're teaching in the game, but also the approach to collaboration that you're trying to facilitate. So there, I guess the question is like, you don't just want to have the models for the individual players, you also want to have a model of their collaboration and the team cohesion type stuff. So have you thought about like, not just kind of an averaging type thing, but also having a model of the team itself?
Right. So we thought that we would need models of teams or groups. I have to admit, I don't have any idea as of right now as how would we go about modeling a group rather than like average players in the group. But in lots of domains, I can see that would be needed. Like, for example, if I know in some of your previous work, you guys were trying to model the goals of players, for example. In some situations, you might not be able to determine the goals of a player unless you actually look at the group as a whole. Because if you look at each player individually, their actions might not make sense, but only when you look at the group, you can actually tell what is the goal. So we might need to do that. I don't really know how we do that, but yeah.
One more question. Just very quickly, there was a setting on context-aware recommendation systems that address a lot of the setting and social setting, etc. that maybe you look at. In terms of my question specifically, I would like to have a bit of your comment on how game designers could approach an always shifting, always transforming, and have an experienced manager on top of it.
Right.
How that balance would go.
Right. So I don't have a lot of experience on that respect. Probably for example, the authors of Facade would have a lot to say here, right? Because when you have to author a game like that has an experience manager that is constantly adaptive, you are not authoring, let's say, a single storyline, but for example, in the case of Facade, you are authoring a story world, right? So it's a very different mindset. It's probably similar to authoring like a choose-your-own-adventure kind of game, that you're not authoring. It's not like writing a book. It's more like writing like a whole space where stories can happen.
Keeping that consistency.
And keeping that consistent. Yeah, yeah. So I don't know if that. Yeah. All right. Yeah. Thanks.
Presenting on behalf of Julian from University of Malta on procedural content generation with equality diversity.
And this is it. All right. I don't know where to sit, so we'll see. Hi, everyone. This is a big group that Mark mentioned. Daniele Gravina is the first author, Ahmed Khalifa is the second author, so they're mainly responsible for what I'm going to be presenting. Our motivation here is, well, title is this. Our motivation is to use the recent advances in quality, diversity, evolutionary algorithms to apply them to PCG. Now, quality and diversity are vital for PCG techniques, and we will be presenting a typology of the different ways in which they can be applied, and some of the uses and cutting-edge research in that domain that have been coming out in recent years. So, well, why do we need quality diversity? Why do we need another type of PCG? We've had discussions over the last 10 years or so about the reason we're generating content in workshops, in conferences, in Dagstuhl, on Twitter. But it's difficult to argue that against the idea that you actually need to have playable content, you need to have, well, fun content or balanced content. These are softer constraints. But playability is a hard constraint that you need. But also you need to have some content that is diverse enough for you to have new experience every time you play. So, you know, if you have a poorly diverse game, you end up with the first version of No Man's Sky where everything is arguably the same. Now, why do we present this again now? Because there's recent advances in evolutionary research, particularly suited for this domain, and these are quality diversity techniques. The idea behind all of these techniques is that you want to promote, you want to find behaviorally different niches in your search space, and you actually just care about the best performing individual in those niches. This work, well, the broader context of this work is not new. There's a lot of work in niching, island models, etc. But the core difference here is that you're focusing on the diversity of the population, the behavioral diversity, so the things that the player might experience, and then you only have quality as a secondary constraint or as a secondary dimension. We have a lot of content in the paper trying to create a typology of the space of PCG-QD, but in the interest of time, I'm going to mention there's components for divergence and there's components for quality, and all of the techniques, all the QD techniques we're exploring fall in somewhere in this space. So when you're measuring divergence, you might want to measure it between one individual and another one, so have a simple Euclidean distance between some metrics. Or you might want to pre-compute your space and then partition it in a way that says, when I'm in this space, I know exactly what individual I have because it represents a specific behavioral feature set. And so then you just fill in the blanks. In terms of quality, the premise is that you want to compete with only your behaviorally similar individuals. So this can be done by, for example, measuring how much you overtake, how much you overperform over your immediately neighboring individuals in novelty search local competition, or in map elites, you're only comparing yourself against the person occupying, the individual occupying that cell that you want to occupy. But there's also other quality components such as hard constraints. So if you satisfy constraints, you're good. If you don't satisfy your constraint, you need to try to satisfy that, and then you will get evaluated on that front. So the benefits of PCG-QD are numerous. Again, I'm going to focus on a few of them. surprisingly, while search-based PCG is quite computationally intensive, it's efficient to use QD techniques because you only need one run. So when you get one run, you will get a broad set of artifacts that are all playable and good to a degree, and they're diverse because you have pre-computed their diversity while you're doing your search. If you're using other techniques such as search-based PCG to just produce one individual, you will need to run it multiple times. Constructive algorithm, same thing. You will need to run this multiple times and then figure out whether this set is diverse. And if it's not diverse, you will need to rerun it. So it's actually quite efficient if that's what you need. Also, you are expressing more by not focusing only on one fitness, but also having a feature set that is not related to your quality, but related to your diversity. It also performs expressivity analysis, which is something that Julian Smith has proposed quite a few years ago, 9 years ago, on evaluating generators. The cool thing about this is actually from many thousands of levels, but MapElites actually does that on the fly. So it actually uses some sort of expressivity analysis to drive its generative process, and it tries to find niches that it has not found before. So it tries to improve the expressiveness of the generator during its own process. Having diverse results that are playable and of good quality is also very valuable for a human machine co-creation tool, so that the designer doesn't get noise or samey results. And finally, because of the visualizations that we saw before, it's very useful to explain what's going on to the person debugging it or to the designer who's trying to use it as a generative assistant. So I'm going to be zooming in on some cases of PCG-QD. We have a lot of them in the paper. Just to understand how cutting edge this is, 3 of these, I believe, were presented this year, and they were not accepted while we were writing this paper. I'm only going to be looking at some that have different generative techniques and different uses. So first up, we'll be looking at Daniele Gravina's work on weapon generation from SIG 2016, where we were trying to evolve pairs of weapons for a 1-versus-1 deathmatch game in Unreal Tournament. We had certain constraints. We found those constraints based on simulations on effectiveness, safety to the wielder, and balance. So we want weapons that are balanced. But then what we did in terms of diversity was try to surprise the generator in terms of evolutionary trends seen so far. So surprise search, in this case, computed the death maps of all weapons that you had in the previous generation. Then all the death maps caused in playthroughs in the current generation, and could predict, therefore, how the death locations would be in the next generation. And then what happened is we rewarded individuals based on the difference from the expected locations. So we wanted them to die in unexpected locations. So the result of this, let's see if it plays. Will not play. Sorry about that. One of the more interesting results was a weapon that basically has almost 0 bullet speed, but it has a high bounce and a high lifetime. So what this results in is in a mine layer, where you just lay mines that float around, and you kill the opponent by having them walk into these traps. In other work by Ahmed Khalifa, we're going to be looking at MapElites here. So this is from Gecko 2018, where Ahmed and the team tried to create shoot-'em-up scripts. So basically scripts that determine the pattern of bullets in a bullet hell game. So since this is a bullet hell, one of the constraints was that there should be a lot of bullets in the level. So at least in 50% of the frames, there should be at least 10 bullets. While in terms of diversity and quality, because this is MapElites, there's a simple quality. You need to be able to survive this level. This was secured through a simulated playthrough. And the space was partitioned in 3 dimensions, whether it was risky and how the bullets were distributed. Let's have a look at the levels produced. So this is one level. I'm not sure who survived this, but apparently A-star can. And then you have a different pattern. So every time you get a sort of a different pattern of bullets that you need to survive through. And this can go on forever. This is a long video. So there's value in doing that during playtime. So the player gets new content every time. But it's also useful to use during design time. And this is my early work on Xenia's sketchbook, which allows the designer to create simple map sketches and can then be transformed into more playable, more complete levels afterwards through constructive scripts. What is important here is that, you have the designer working over here on their own canvas, and the AI assistants are evolving maps based on the human sketch towards different objectives. The user can take these suggestions and replace their own sketch. What is important to note here is that I had a multi-threaded approach where I had 6 suggestions over here. Each one of these was generated by one thread, so we had 6 threads to optimize one fitness each. I had several different fitnesses, and then one thread to generate these 6 novel suggestions that were still ensured to be playable. And that was done by having constraints on reachability of paths, and also measuring tile-to-tile similarity. So instead of having 6 threads to create 6 suggestions, I could have 1 thread to create 6 suggestions. And that kind of shows you how you can save computational time and have a more efficient system. I will probably skip the next few slides because I really want to talk about where we want to take it further. So there are some issues still with this line of research. Even though you can have a more expressive range, it's very difficult to kind of go beyond 2 dimensions for your visualizations. And once you start diluting it into 7 dimensions, you always have the issue of, now I'm measuring diversity on a very, very vague and difficult to compute space. Also, it would increase your computational time. So this is still something we want to work on. We also want to work on enhancing PCG-QD approaches with machine learning in the vein of PCG-ML. You can do this to create good content based on a corpus, so things that match patterns found in the corpus. To evaluate, instead of having a simulation, to evaluate them through a machine learned model. This is based on a presentation I also had this morning, but also to measure diversity in a more expressive space in the latent representation rather than on a pixel-by-pixel basis. We also want to enhance explainability. We have it there in the paper that it's actually a very useful technique for explainability, but we want to explore further and put it to use and test. And one kind of like out-of-the-box approach is that we can use PCG-QD focusing on the mechanics of as your behavioral space to create contents to train reinforcement learning agents. So you can create many levels that require many different mechanics, many different sequences of mechanics, and use that to train your RL agents. Okay, I'm going to briefly mention here that there's going to be a conference next year. It's going to be in Europe, and it's called the Foundations of Digital Games. So if you're interested in AI PCG design, it has a bit of a more design-oriented scope, but definitely a rich tradition in PCG and AI. So let me know if you want to know more. Thank you. Yes.
In terms of the really interesting talk, in terms of the sorts of thoughts that might be going through the head of a game designer, can you say a bit more about the explainability and what you think the system offers?
So it allows, I guess I'm going to change your question to talk about controllability instead, maybe. As I mentioned, we are still exploring how explainable things are. The fact that you can basically run this and get an expressivity map is already quite good. to provide you with a, so that you know exactly where how the search space looks like, where the more promising content is. But you can also tweak those by just changing your feature dimensions, and then seeing it multiple times. Yeah, that's.
No, it's the ability to play with it easily.
Exactly. Yeah. And there's definitely a lot more that I cannot think of because we have not thought of, but it's definitely something that we want to explore a lot more in the future. Anyone else? Sorry, Rafa.
Can you go back to the previous?
I can try. I think I broke my computer.
Yeah. So when it's probably not to measure diversity, but to get insight into it, right? So I mean, there are many algorithms to lower dimensionality and give you very protected ability.
Right.
Yes, for example.
Which we don't know what they mean. But.
Well, but you have to see clusters, and you can zoom into it and look at one cluster and look at the other and see, oh yeah, I get insight into it, although I cannot measure it.
This is a broader discussion that I would love to have. So whether you want expressivity analysis, for example, just as an example, to be intuitive in terms of your dimensions, or whether you just want it to be to capture as much of the search space as possible. Because TSNE and other techniques can lower dimensionality, but then who knows if those clusters mean something. So it's definitely
very useful to get insight into the high dimensionality data.
There's also one more thing I can preview, let's say. You could also have designer models of features, so you can basically, because of this designer is interested in these particular dimensions, they keep tweaking, that particular dimension, you might want to have them specifically tailored to the designer because that's the kind of games levels they want to make or whatever. Yeah. Mike?
So you said that this process kind of increases the expressivity, I think you said, compared to expressive range.
It explicitly targets expressivity, let's say.
But what you're actually doing is it's almost like a randomized expressive range analysis, like in Gaina, right? Because you're actually searching through a hyperspace. You're not actually, expressive range is what is this generator doing right now? So in your mind, does the game ship with map leads inside it, or does it, you know what I mean? Because
no.
Normally you fix the generator with a set of parameters,
right.
map leads starts searching through that space as well, and it's
okay. No, okay, hold on, because I think there's a few things. So expressivity analysis is often used to tweak, to tweak your generated parameters. But here we're saying that you have a generator and it has a set of parameters. These parameters are broader because we're talking evolution, so it's you need to be able to create a lot more content. And then you can use expressivity analysis to maximize the breadth of content you can create with these parameters. So it's not about parameter tweaking.
You're filtering within the not filtering, but search.
Yeah, you're searching within those. So it's not about tweaking the parameters of your let's say your scripts or your range of values within your array of floating points, but it's rather to generate content that is as diverse as possible with these parameters.
That's really interesting.